Okay, so in this part of the video, we will talk about the update initialization parameters that governors will be able to set and initialize markets action, which is the contract that is executed when we do this quarterly roll of Fcash markets. So maybe Teddy, do you want to give us like a quick high-level overview of what rate anchors and proportions are, like knowing that we're going to kind of dive into these in more depth when we look at the initialized markets contract?
Okay. Actually, sorry, Jeff. Can we?
Okay. Well, you want to cut this and start over?
Yeah. Sorry. So what rate anchors and proportions are?
Do you want to do that, or do you just want to? Do you want to skip that? Because
Yeah, I don't. I'm not sure if that's like super relevant, to be honest.
Okay.
Or
Why
like,
don't we just talk about it in context of initialized markets then?
right. Because I don't like. Is it super necessary for them to know what rate anchors are? Like that's you know what I mean?
Um, why don't I just mention this here? But like, just I'll just talk. I'll just give a quick highlight. So the rate anchor is actually only used in this branch here, right? I'm pretty sure.
Yeah, the rate anchor is just used like when we
initialize new markets.
yeah.
Oh no, we use it here too. Is that correct?
Where?
Right here.
What does this do?
This is when you're over the leverage threshold.
Oracle rate. I don't. I mean, what is this doing? I don't understand. So
we've calculated. So the proportion is over the leverage threshold. So we're going to set the proportion to the leverage threshold, and we're going to calculate the total F cash as at the. We're going to calculate the total F cash at the proportion.
Yeah. So basically, yeah, that's right. Because
right.
Yeah, because this one is like so this one yeah. So the Oracle rate is going to be yeah, because like so we solved for what the interest rate should be, and it implied a proportion that was greater than the leverage threshold. So like now we're setting the proportion to the leverage threshold, and we're back solving for what the Oracle rate should be. Like yeah. So this is the case where we do change the Oracle rate.
Right.
Yeah.
But we in all cases here we use the rate anchor from the parameter. We don't use.
Yeah.
That's correct.
As opposed to what?
As opposed to like solving for the rate anchor based on the last implied rate.
That's correct. Yeah. So we're always going to use the rate anchor that's like saved. Yeah.
Right. And the reason is just set the proportion.
Yeah. Just so it gives governors more control. So it's like we can it gives us the optionality to like to just like get the liquidity curve kind of where we want it.
Right.
Yeah.
So.
And it's also, you can't solve for two variables, right?
Okay. Sure. Yeah, that makes sense. Okay, so why don't we just say that? So I'll just say like the rate anchor is used by governors to so it might be helpful here to have this image this image here to basically say the rate anchor is going to, the governors can use the rate anchor to try to put the curve, try to maintain, like try to get you in the flat part of the curve, right? That's essentially.
I'm trying, and like it's hard that what should we say the rate anchor is for? Yeah. It orients the curve in the XY plane. Uh, do we need to say what it's for? Can we just say what it does?
Yeah, I think you can just say what it does. It can be succinct.
So
I think this explanation is fine.
The rate anchor, yeah, the rate anchor sort of just orients, but that's so abstract. I would just say like the rate anchor defines the interest rate at a proportion, at a 50-50 proportion.
Right.
Like, or they defines the exchange rate, interest rate, exchange rate.
I'll just say, yeah, it's like, I'll just say we need it to kind of like orient the liquidity curve on the XY plane. But we solve for the proportion to like maintain the interest rate. Okay, so let me, what do I do here? We'll just start recording now. Okay, so okay. I'll just cut that initially. Okay, so in this video, we will talk about Initialize Markets action, which is what happens on every quarterly roll when we roll the Fcash markets forward another quarter. And so the two parameters that are relevant just for Initialize Markets are the rate anchors and proportions. There's one of these per Fcash market that's actively traded. So we'll talk about these in more detail as we go through the Initialize Markets action contract, which is called when we roll Fcash markets forward. But I'll just mention what these do at a high level now. So the rate anchors, what that does is it sort of sets the, sort of defines where the liquidity curve will be in the XY plane. So as we discussed in the Fcash markets video, the rate anchor is sort of the offset from the x-axis. And so that rate anchor will change as the Fcash market trades over the quarter. But when we initialize it, we use sort of a default value. And that allows governors to sort of control sort of the initial, where the liquidity curve is initially and hopefully optimize like to minimize slippage a little bit for users. The proportions, so this value is really only used when we initialize markets for the first time. Every subsequent time, we're going to sort of solve for the proportion of Fcash to cash in conjunction with the rate anchor to ensure that the annualized interest rates of these Fcash markets don't sort of diverge too much when we roll them forward. And we'll get into that in a little bit more detail. So, so governors will set these two parameters, and from there, what we have is a method called Initialize Markets. Now, this is an unauthenticated call, so anyone can initialize markets when at every quarterly roll. And so, what we're going to want to make sure is that after every 90-day period, we call Initialize Markets very soon after the previous markets expire. So the new markets are launched, the new markets have liquidity, and trading can continue. So that little time period between when the markets are done and when we call Initialize Markets, we want to minimize that to as short a period as we can. So with that, we'll walk through Initialize Markets. That's really, we can think of this function as doing two separate things all at once. So the first thing it does is it settles out the end token portfolio from the previous quarter. So it settles out all the liquidity tokens. It creates these Fcash residuals, and then we calculate how much total asset cash, how much total C tokens we have to then provide liquidity to the new set of markets that we're going to launch in the next quarter. And once we've done that, we're going to calculate the proportions, the Fcash and total cash that are going to be in those markets that will sort of maintain interest rate continuity between the previous quarter and the current quarter. So that's a lot to kind of adjust, but we're going to go through this step by step. So we'll look at calculate net asset cash available first. This does a few things. So we're going to scroll up here to find it. So calculate net asset cash available. So important to note, we do have a special case when we're initializing markets for the first time. We don't have anything to settle out, so it is a bit simpler. So we'll just set this variable last initialized time on the end token. And what this gives us is a reference for the next time that we initialize markets. Now, the first thing we'll do here is settle the end token portfolio. So this will behave very similarly to how we settle regular user portfolios, with the same caveat that end tokens have both the array portfolio and a bitmap portfolio. So this method calls the two methods that we saw in the settlement video, and sort of adds up what the cash balance will be after settlement. So we'll kind of refer to those videos here. The next step is to get the previous markets. So we use them. So generally, the way the code works when we load markets is we'll fetch the markets that are currently relevant. But we have a special case here in Initialize Markets. We need to reference the Fcash markets that just settled. So we have a special sort of method call for that, load market with settlement date. We also use that when we're settling Fcash or settling liquidity tokens. So this is just a function to ensure that we're referencing the proper Fcash data when we go through this method. Now, the next thing that we do is we withhold and set the Fcash assets. So you'll note in the settle portfolio method, when we settle liquidity tokens, if there's no matching Fcash asset, and maybe it's best just to look at this again. So if there is, so when we settle a liquidity token to Fcash, this is sort of the remaining Fcash asset will be the Fcash residual. When we do this in the end token portfolio, since there will be no matching Fcash assets, all the liquidity tokens will be sort of updated to reflect simply the Fcash residual. So at this stage, the end tokens portfolio state will be full of the Fcash residual amounts after settlement. Now, we'll do a transformation here to move those residuals from this portfolio array into the Fcash bitmap so that they're set properly in that portfolio. And so that's what this loop is doing. The next thing we'll do here, now that we've sort of, like at this stage, we've sort of kind of properly set up the end token portfolio. We've like settled things out and we've sort of put the assets where they need to be in storage. What we're going to do is something called get end token negative Fcash withholding. Now, we discussed this particular parameter, the cash withholding buffer, in the previous video on end token governance parameters, and this is where we will apply it. So what we're looking for are assets in the end token Fcash portfolio, the bitmap portfolio, that have a notional of -0, or sorry, less than 0. So these are debts these are kind of like debts that the end token holds as a result of these Fcash residuals. And what we'll do is we will calculate the oracle rate. Note that there's two sort of scenarios here. We'll discuss this, like why this branches a bit later in the video. But what we're doing here is we're going to calculate what the sort of oracle rate for the end token for this particular maturity is. And then we will sort of bump that a little bit and get the present value of that. So we'll withhold that amount of cash as collateral against this debt that has been this Fcash residual debt. I don't know, Teddy, do you want to add anything to what I said there?
Yeah, and so kind of like what we spoke about in the last video, where we need to ensure that the end token account has enough cash to cover any debts that it holds. So if somebody wants to come in and purchase that residual, the end token account is going to need to have cash to complete that transaction. And so what this buffer that he's talking about does is it essentially says, okay, so let's say current interest rates are 7%. Let's assume that the end token has to trade at a much worse exchange rate. And so it's going to hold more cash than it needs given the current level of interest rates, just as to hedge against the risk that interest rates move a lot in the wrong way before somebody comes to purchase that residual, and just make sure that even in the case where interest rates move significantly in the wrong direction, the end token still has enough cash to complete the residual purchase transaction.
Right. So the kind of net effect of all of this, all these calculations will be the amount of asset cash withholding that is required to keep in the end token's cash balance. And the difference between that and the actual cash balance that it's holding after settling out all of its liquidity token positions will be the amount of asset cash, the amount of C tokens available to provide as liquidity to the new set of markets that will be launched. So we do a quick check here that there is enough asset cash available to at least kind of minimally go across all the markets. This is quite a low number. So we should always be passing this check here. Now we'll skip some of these other methods here and go back into Initialize Markets. So we've reached this point here. So we know how much cash we have available to provide as liquidity. So we will get the governance parameters we discussed earlier. And now what we're going to do is loop through all the markets that we need to sort of initialize for the next quarter. And what we're going to do is essentially set up their state. So the first thing is a little bit easier is setting the total amount of liquidity and cash available. So that will simply be based on the deposit shares. So what proportion are we depositing to each market? We're going to put that amount of cash into each market initially. So looking at this method, we see it's fairly straightforward. It's simply getting the proportion of the total cash available, setting that as the total asset cash, total liquidity, and adding the appropriate liquidity token into the end token portfolio. Now, the next step is a little bit more involved, which is calculating how much F cash we're going to put into that market. What that does once we put the F cash in is it's going to set the proportion of total cash and F cash, and that in conjunction with the rate anchor that the governors have set will set the initial sort of interest rate for the market. And maybe Teddy, do you want to take it over here and just talk a little bit about what kind of requirements we have when we set that interest rate?
Yeah, sure. So basically, the issue here is that so we previously had a set of Oracle rates, right, that have now expired, right, because all the markets have settled. And so now we're going to have a new set of Oracle rates, right, that are defined by a different set of maturity dates that are 90 days forward. And so the question is what should the interest rate of these new maturity dates be? It shouldn't be the exact same as the old interest rates because they're different maturities. But what should it be, right? So how should we decide what these interest rates are going to be when we initialize? And so effectively what we do is we solve for new interest rates at these new maturities that keep the old interest rates at the old maturities constant, assuming, with the way that we interpolate the interest rate curve, right? So basically, like you can think about it like, you know, we will have a 9-month if cash asset that has just matured. And now we're, you know, in a position of deciding what we want the 1-year interest rate to be. And essentially what we're going to do is we are going to solve for the 1-year interest rate such that the 9-month interest rate remains unchanged from what it was before the market matured. So that's how we're solving for this new set of Oracle rates. We're solving for the new set of Oracle rates that keeps the interest rates at the maturities that have just matured the same as what they just were. Yeah, and the idea is like we want to keep the value of the Fcash assets that have just matured constant across the roll. Yeah.
Okay. Yeah. Thanks, Teddy. And so what I'll do now is like kind of walk through the different cases like that might occur when we kind of do when we do these calculations, right? So there's two branches to this if statement. So we'll look at the first one and then we'll look at the second one. In the first case, what we're doing here is we're simply using this proportion to set the Fcash amount. And this proportion is set by governance. And the cases that we will use this are essentially when we're like somewhat launching a new market, right? When we don't have like enough reference data to actually calculate what this rate should be. So the cases when that'll happen is when we're first initializing the market for the very first time. When we have only 3 and 6 month markets, we don't have enough data to sort of interpolate that rate. And so the 6 month market is sort of like new every time. And so when that occurs, we're going to use the governance data to set the proportion for the 6 month market. Right. So if the case is that we've reached the point where the N token does not have assets, and we're sort of like, it does not have a liquidity token for the previous quarter, and now it must have a liquidity token. What that means is that we've just launched a new market, right? So governors have increased max market index from maybe 2 to 3 or 3 to 4. And so we need to initialize that market for the very first time. And so what we'll use is the values that governors have set. Now, there's another edge case that has to do with how we calculate this Oracle rate. So when we move from the 6 month to the 1 year market, we sort of have to initialize them like both as new. And this just kind of has to do with, I guess, a little bit of idiosyncratic kind of logic around how we calculate this rate. I think the reason here is that we don't have like two interest rates to refer to in order to like draw that interpolation, right? Teddy, do you want to?
Right. Yeah. No. The issue there is basically like we could hypothetically use. I think the issue there was that we didn't want to rely on the compound lending rate because it's so volatile. That it can change kind of from one moment to the next. So it's not like it. Yeah, we didn't want to rely on it as like how we were going to draw the curve. Yeah, so
Right.
that was, I think that was the reasoning there. Yeah.
Right. And so that's kind of like a similar reason why in this case we sort of initialize the 6 month market as new every time. When we only have one market, the three month Fcash market as a reference point, we don't want to draw the curve using sort of the 0-day rate, which is sort of the compound rate, since it can be volatile. So in this case, what we do is, we calculate the Fcash amount based on the proportion, and we set the Oracle rate to the implied rate, the implied annualized interest rate of this particular portion, total Fcash, and the amount of underlying cash going to the market, and the rate anchor that has been set by governance. In this case, in the other case, we still have a couple special cases. So because the 3 month and 6 month markets are sort of like 90 days apart, when we do this quarterly roll, the 6-month market will now be referring sort of exactly to where the 3-month market should be. And so for the 3-month market, when I equals 0, the kind of shortest market, it will always sort of inherit the 6-month market interest rate. Now, it's important to note here that we have logic in the cash group.sol file that prevents governors from initializing only a 3-month market. Otherwise, this kind of logic would always fail. So the minimum amount of markets, Fcash markets, for a given tradable group is always going to be 3 and 6 months. So this is given the case that we, so in this second special case, again with the 6-month market, since we don't want to use that compound like 0-day kind of like interest rate, we refer to the previous, we sort of interpolate between the 3-month and the 9-month markets, which to get the 6-month market. So typically in sort of every other case, we're going to sort of draw the line forward. So we're going to go like through like the 6-month and the 9-month to get like the 1 year to kind of like go forward. But in this particular case, we're sort of interpolating between. So the math is sort of the same in terms of like we're trying to draw a straight line. We're just using points, like different points to do it. So this is, again, just to be totally clear, this is like slightly different than this particular case. This particular case is when we are initializing the 1-year market for the first time. We don't have the reference data. On the second time, when the 1-year market is sort of like we're rolling it and we do have that data available, we will sort of, we'll definitely use it here to get the Oracle rate. Maybe people watching this will have to like listen to this a few times. So what we're doing in these two branches here is we are calling two methods that work quite similarly. What they're doing is they're interpolating the rates. So they're doing a linear interpolation between these sets of rates. And we can take a look at that code quickly here. So we'll just look at interpolate future rate. Then the 6-month rate works pretty similar to this. Won't like kind of dive into all the nitty gritty here, but essentially we're doing a linear interpolation here to get the interest rate based on where it sits on this line. So once we've done that, once we have this Oracle rate value, what we're going to do before we sort of call it a day here is we're going to check what market proportion this implies. And the reason we want to do this is that we don't want the N token to provide liquidity at a proportion that's too high. We have this leverage threshold there to as a safeguard against the N token being over levered. And so we want to make sure that that still holds when we initialize markets here. And so what we'll do is, given the values that we have up to this point, we're going to calculate what the market proportion is. And then we're going to test if that proportion is greater than the leverage threshold that we've set for this Fcash market. If it is, what we'll do here is we'll simulate lending. So we will reduce the Fcash in the market down to where the leverage threshold should be, and set the Oracle rate according to that new proportion. And so what this is going to do is lower the interest rate from what the interpolation says it should be. But this is sort of simulating the behavior that the N token would take regardless. I don't know, Teddy, do you want to add anything to that?
I think that's about right. It's just the idea is that, like, okay, so we have these leverage thresholds for a reason. We're not going to provide liquidity in the N token above the leverage thresholds. And so given that, what would we do, right? We would provide liquidity and then lend down to the leverage threshold anyway. So we're just like, what we're doing is we had solved for this proportion that turned out to be too high. And so we're just going to provide liquidity at the leverage threshold proportion and then back solve for what interest rate that implies. And the interest rate it implies is going to be a little bit less than the interest rate that we had solved for. But that's what we're going to do.
Yep. So there's a method call in that code called get proportion from Oracle rate. So I'll just show it here. Sort of the math is above, and might be good to kind of go through this. I don't think there's any like kind of usefulness in kind of going through this math, but essentially what we're doing is we're getting the market proportion from the Oracle rate that we've set here. So now what we'll do is we'll finalize this loop. So we'll check for some edge cases here. We'll set the Oracle rate on the market, and we'll set the trade time to the current block time. So that's sort of like make sure that this Oracle rate is going to be what the users actually get. There's not going to be any sort of averaging, because we know it's going to be set to the current block time. The last implied rate will also be set to the Oracle rate. So that'll be like the new rate that this Fcash market is going to trade at. And then we finalize the market here. And what this is essentially doing is it's going to go ahead and set the market's storage slot, has a sort of a special storage state here, and write that to storage. And again, so the market will have a total Fcash amount, and we are going to add the negative side of that to the end token account, right? So this is exactly how we provide liquidity. We make sure that there's the positive and negative Fcash pair, and that's what we're doing right here. With all those set, we will sort of then set the end token portfolio, the end token storage. So this is just kind of writing all these things that we've calculated storage. And at this point, we have initialized the markets, and they should now be available for trading, for lending and borrowing for all users. I will also mention that there's another external method in this contract. It's called sweep cash into markets. So what this method does is it can be called by anyone after markets have been initialized. And what it does is it recalculates how much negative Fcash withholding, like how much cash we need to withhold for the assets, for any residual assets in the end token account. And then it sort of provides liquidity with all of the cash balance available in the end token back into the markets. What this is useful for is when after the residuals have been purchased, so if the Fcash residuals are positive, after they've been purchased, there will be sort of a large amount of cash sitting idle in the end token portfolio. And we want to make sure that that goes back into providing liquidity, so there's no sort of drag or kind of like dead weight. And so this can be called any number of times. What it basically does, is push that liquidity in and sort of always ensure that the end token still does have this amount of cash withholding. So with that, we've talked through initialized markets. This happens every quarter. It's like really important for the functioning of Notional. And also just want to kind of step back and talk about like why we even built this kind of thing. And one of the core reasons is that we wanted to make sure that providing liquidity in Notional can be very user-friendly, right? In Notional V1, liquidity providers would have to come in and each of them manually do this process of like rolling their liquidity forward. And like the first liquidity provider would have to sort of do these sort of calculations on trying to figure out where the initial like liquidity in the market should be. And what we've done is sort of taken that away and given that responsibility to governors and sort of make the end token a non-maturing native ERC20 token. And we think that's like a really powerful sort of part of Notional V2. I don't know, Ted, do you want to add anything to that?
Yeah. I think that's absolutely right. So it's sort of basically like one of the biggest things that we sort of noticed from Notional V1 was just how much of a drag on like how much engagement was required from liquidity providers, and just like how much more engagement was required on Notional V1 than on sort of other DeFi applications from liquidity providers. And so wasn't giving them a great experience. Liquidity providers are super important in Notional. And so, we wanted to do something that would be user-friendly and allow them the sort of passive exposure that they get elsewhere in DeFi, and also have something like an ERC20 token that would be easily integratable into sort of other DeFi protocols. So, the end token is great collateral, it's high yielding. We could see it being used as collateral on other lending protocols, and it also integrates well with sort of protocols that might be doing, yield aggregation or sort of like batching up yield farming. It can work quite well in that context as well. And then also just the last thing is like, kind of what Jeff was saying about, every time the market is rolled, somebody has to go and initialize the new market. And that it not only requires someone to like really understand how Notional works, it's also very dangerous, because you can imagine that like as the system gets quite large, if all of a sudden you have someone just set where the new interest rate is, it's too much power for an individual user to have who doesn't necessarily have the interest of the system at heart. And so it's quite dangerous. And in fact, like doing it this way is safer and more stable.
Right. So that's Initialize Markets, and we'll be back with kind of more videos after.